All right, good afternoon. Okay, just go ahead and type any questions that you have. And like I said, I mentioned yesterday, my default is, I'm gonna just mute everybody here. Mr. Williams has told me he's willing to help anybody with math. So if you feel like you need to reach out to him, Mrs. Gillis is my co-teacher for this class. That would be another as well. Oops, that's not the slide I wanted. So this is just talking about the different, sorry, not meaning to give anybody a seizure right now. Great, I'm recording this. Okay. So I know this is what I think of when I think of math, but there's some things that you'll be strong with, some things that are hard. And one thing I want to let people know is that whenever we have like a complicated math problem at work, you'll usually see 3-4 of us techs kind of all getting together, working on it together. You know, there's some basic math and some basic things that you should be able to calculate day one when you go into a clinic. But I can tell you, sometimes they're like, we want to put this puppy on a, you know, on a 2.5% dextrose solution, and I want to add metoclopramide to the fluids. And y'all kind of look at each other like, okay, let's figure this out. So, you know, there's some of it that'll be intimidating. And I know a lot of clinics personally that have a lot of online calculators, like literally you type in the animal's name, you put in their weight, you click the drug you want, you click the fluid, it calculates everything for you. So the nice thing, I didn't have those back in my dinosaur days, but now there's lots of these online calculators. But the problem is when you take the boards and you do skills, and it is good skills because sometimes we want to double check. Even if I have an online calculator, sometimes the doctor's like, let's work it out, make sure it's correct. So I do want you to know, you know, I'll definitely try and stress things that are very basic things that you should be able to do. And hopefully some of this is, you remember that you did maybe with Mr. Williams but I will tell you, everybody has strengths and weaknesses. I am no math whiz. I can do the math that I need to do for my job. Basically, some of the things that you need to be able to do, obviously, work through drug doses, because a doctor's going to say, I want to give my patient 5 mg per kg of, you know, drug A. Propofol, let's calculate 4 mg per kg, and it's 10 mg per mil. And then you have to figure out, because when we record it in a chart, you don't just put mils. You have to write how many milligrams the patient got and how many mils. So when I write out my calculations, and anytime I ask for calculations, and we will do these also in anesthesia, you'll have to write the milligrams and you'll have to write the mils. Attend this one, fluid rates, and this you guys will go into a little bit more. Fluid rates will go into Tech 4. You talk about maintenance fluids, you talk about replacement fluids, constant rate infusions. So I don't get, in pharmacology, I'm not going to do a lot about fluid rates. That'll be more in your Tech 4. Obviously diluting chemicals. So sometimes when we give a drug and we have to do it in a dilution, we have to do a dilution factor. Sometimes when you run blood chemistries, you have to run a dilution factor. And what that means, I will tell you, sometimes cats in renal failure, their BUN or their urea nitrogen is so high, the machine won't read it. And you have to dilute it out. And it'll say it wants it in like a 1-to-4 dilution, a 1-to-3. And so being able to understand dilution, not only sometimes of drugs, but sometimes we're diluting lab samples so that the machine can run it. Like I said, sometimes we'll get a glucose that's too high. a urea nitrogen that's too high in the machine. We have to run a dilution factor to get the accurate value. So it comes up sometimes in more than just pharmacy. But basically, one thing that we're looking at is you have to work with percents, decimals, and sometimes ratios. You know, like we were just joking, talking about shopping at Meijer. And, you know, if it says something is 20% off, that's something that you should be able to do in your head. You're like, well, if it's $20, okay, and 10%, we move the decimal. If we have $20, $2 is 10%. So 20% would be $4. If I take $4, subtract from $20, the item is $16. Obviously, when you talk about 50%, that's half. So if something was $20 and it was 50% off, that would only be $10. That's half of what, you know. So you have to sometimes think about percents, and, you know, you have to change that. But think about like when you're shopping and you see a sale, sometimes you can work that through in your head. Also, reducing fractions is something that we get into. And also changing, and let me type it here. So say, for example, something said it was a half. Well, we know a half is, where's my little equal symbol? So a lot of times someone will write 0.5. Some people will write 1/2. They both mean a half. And so interpreting what that means. And then if we have another, and these you can actually potentially write down on your own. If you have 1/10,000, sorry, I'm trying to type this fast and my cursor's there, equals, I'm trying to do this, and gosh, why am I? Okay, so what I just typed in the chat screen is that 1/10,000th is also equal to 0.01%, which is also equal to 0.1 mg per mil. So, you know, there's going to be, most of the time we're working in 0.1 mg per mil, but sometimes things are represented as a ratio or a percent, and we have to be able to interpret those instructions. And never feel bad. You know, these are things that hopefully in math, you're remembering some of this and you're comfortable with it. But I know sometimes we always ask each other at work, can you help me figure this out? And everyone should be able to help each other, because some people are good at math and sometimes that's not a strong suit. This was in a video yesterday, but the measurements that we work with, this sometimes gets confusing because the household system, it really doesn't, it's not as standardized. It's not usually as accurate for measuring medicines. If, you know, the apothecary system is, you know, what the pharmacists will typically go by, and that has a little bit more standards. And then the metric system, you know, for a long time, the United States, took them a while to get into the metric system. And now more and more drugs, especially when we get drugs from, you know, Europe, and a lot of times they get anesthetics before we get them in the United States. And so we maybe were working with like mgs per pound, and then they were working with kilograms and in the metric system. So things I think are shifting more to the metric system than maybe they used to be. But okay, we're going to talk about that. So really we're going to talk about factors of 10, and when the metric system goes with that prefix is going to kind of help you determine you're going to have to know what is the standard unit. And if we go up or down from the standard unit, Usually the prefix in the word tells you the size and what we're doing. So if you look at here, the yellow box in the middle is our standards. We're going to work, if we're working with liters, grams, or meters. Now, most of what we're talking about in pharmacy is liters and grams, okay? But if we're talking about distance, we talk about meters. That is the standard. So this is 1. The yellow box would be 1. If we're going to go up, like a kilogram is going to be more than a gram. And then if I go down, a milligram is going to be less than a gram. So if you go up with the darker numbers, that's going to, and every time it goes up, it's 10 times this. Okay, so if this is 1 and a kilogram is 1,000, then that means 1 gram equals 1,000 kilograms, if that makes sense. And then if 1 gram is here and you're going down, if you divide by 1,000, a milligram would be 1/1000th of a gram. Okay, so, you know, these charts are good to write out. These charts are maybe good to have handy. I will say there is, we're going to talk about conversion factors. In your Plum book, and I want to say it's in the appendix. Mine is in the other room right now. I should have brought it in here. But inside that book, it does have the conversion factors. You may, if I were you, if it had them like on a page, you might want to take a picture with your phone and you have kind of like a handy reference on your phone, so you're not trying to like sometimes flip through the book. You'd have the conversion factors right in front of you. So this is probably the most widely used. Like I said, overseas was used almost exclusively, and that has become more popular here. The factors of 10, meter is length, and then liter is volume, and then we're going to talk about gram is weight. So we have length, volume, and weight. 1 meter, 1 liter, 1 gram is where we start in the middle, and that equals 1. Now, again, we're going to be in medicine, we're mostly working with liters and grams. If we look on here, we're telling you which way you're going. Now, I talked about milligram, and usually most drugs are listed in milligrams. Like metronidazole, a pill we use for diarrhea. 1 pill is 250 milligrams. 1 mil of propofol is 20 milligrams, okay? We do have a few drugs that we use in veterinary medicine that go down to micrograms. If you've heard of dexdomitor, dexdomitor is a sedative that we use pre-surgery, sometimes to sedate for x-rays, used all the time in veterinary medicine. It is listed in micrograms per ml instead of milligrams per ml. So I will tell you, you have to be very cautious when you're working with a drug. Are we working with milli? Because that's 1,000th of a unit, but microgram is 1/1,000,000th of a unit. So if a doctor says, I want 1 microgram of a drug, or I want 1 milligram, you know, that can make the difference in the dose. And then kilogram is how we usually weigh our patients. Don't really use centigram much. We really work with kilogram, milligram, gram, and microgram. And another drug that we use, sometimes we use a drug called sucralfate for dogs that have ulcers. It's a protectant. It comes like a giant horse pill. It's huge. And they are 1 gram tablets. So that there's a few drugs that are listed in grams rather than micrograms. But I would say milligrams. Milligrams, most of our drugs you work with are milligrams. Some are micrograms and some are listed in grams. Now, if we look at here, this is telling you the prefixes, okay? And they've added the prefix to the base unit. So a kilometer is the base unit, is times 1,000 for distance. Kilogram, 1,000th for weight. And then volume in liters is in liters. So you can see the chart here. They're just telling you, again, which way you're going from the middle, okay? If you're going up, and then this is also, are you multiplying or are you dividing? Depending on which way you're going, is whether you're going to multiply or divide. Now here is some guidelines. One thing, I'm not gonna, you can read this slide. One thing that I want to, the Arabic numbers are standard numbers. Decimal fractions, so you can have 0.1, 0.01, 0.001. However many zeros you have is equal to 10, okay? So 0.1 is 1/10 of 1. 0.01 is 1/100th of 1. And then you see we work our way down. One thing that I want to stress is number 3, and I think this was a question on the homework that was in the video, is, I'm getting a pause, hold on a second. Okay. If you're going to write, if an animal is supposed to get 0.1 mLs, you don't want to write just a dot and a 1, because if for some reason that dot got erased or smudged or someone couldn't read it, you made a really tiny dot, they might interpret it as a 1. Well, I'm going to tell you, 0.1 mLs of a drug is very different than 1 mL of a drug. When we get into anesthetics and potent anesthetics, a decimal point can be very detrimental to a patient. So it's always better to put the 0 in front of the decimal if there's no whole number. If a dog was supposed to get 1.3 mLs, that is easier to write because you've got a 1 in front of the decimal. But again, if it's 1.3 and something happens to your dot and someone thinks it's 13, that's very different. But a lot of people sometimes leave off the 0 when they write like 0.1 or 0.2 or 0.3. Always put the 0 so that we know that it's the proper, that there's not a whole number. Let me see if there's something else I want to say on here. The commas, obviously, if we're going up, a lot of times people write 1,000 without a comma, but once we go up from there, the more zeros you add, it's better to write the comma so that, we can interpret that number better. And usually when we write fractions, if a dog gets 1.5 mLs, it's better to write 1.5 versus 1.5, how it's written with the fraction, okay? So most of the time when we're writing in a medical chart in pharmacy math, you're not going to use a decimal, or you're not going to use the fraction form. You want to use a decimal fraction. So that's why it's important to know your fraction converges into decimals, because that's how we have to record it. This is a nice little chart because it actually, sorry, someone was trying to get in again. Hold on. Okay. So if I look at these stairs, and these are stairs, sometimes, there's that dot. If you guys have ever used that in school, there's the middle, and then there's the line, and it goes up or down. This is the same, just stairs. You have your base unit, which is this blank stair. If you're going to go up this way, you're going to divide. If you're going to go down, you're going to multiply. So if I have 1 liter and I need to know how many milliliters it is, I'm going to multiply that by 1,000, okay? 1 liter is 1,000 milliliters, okay? And if we're going to go up, we're going to divide. So if I have a kilometer, it says I want to know how many meters it is. It's 3 hops down from the kilometer. Okay, so here's the kilometer up here. And I'm going to go 1, 2, 3. and it's gone up to 1,000 meters. 1 kilometer is times 10 times 10 times 10. The same thing on going up the stairs is moving the decimal. Okay, so if you're hopping up 3 stairs, you're going to add 3 0, or you're going to go from the 1, you're going to go 1, 2, 3, and that's 1,000 meters. Okay, just like if I have 1 liter, 1 liter is 1.0. If I move that decimal 1, 2, 3, and I fill that in, I have 3 zeros. So this is where conversion factors get in, is knowing which way you are going. So now this is what, let me get into something, because this has become, when we will calculate math in pharmacology, normally you're going to be using a calculator, 4-function calculator, and in that 4-function calculator, you're going to multiply and you're going to multiply and you're going to get a number. And if it says like 1.46, people might want to round that. You should leave the math in your calculator all the way till the end. You might have 1.4678, and then obviously you can't draw up in a syringe 1.478. How do we round up? Rounding up or down is going to be up to the veterinarian. Now there's some drugs like metronidazole, or sometimes like an antibiotic, that if we go up and down, you know, or if we go up, rounding, it's probably not going to be a big deal. Some drugs have a wide margin of safety. But let me get into anesthetics. If you have like a small cat and you round up even a little bit, it might be too much for that cat. So when I talk about anesthesia, I talk about what patient factors influence me rounding up or rounding down. Because the anesthesiologist trained us, you know, on our own. I could look at a patient on my own and say, I'm going to round up or I'm going to round down. But I would look at, you know, temperament, age, health status, procedure. You know, if I've got old frail kitty that's coming in for a dental with 3 teeth hanging out of its mouth and it's hanging by a thread, I'm probably going to round down. If I have the Labrador that's 1-year-old for a spay and it's like bouncing off the walls like a pogo stick, I'm probably going to round up. So it really depends on what you're treating. It depends on the drug, depends on the patient. And, you know, when I get it, you'll learn certain drugs, I have wiggle room, and certain drugs give very little wiggle room. So it's going to be, it's going to be up to the vet. So you don't want to round till you get your final answer. Because what you guys will do, you'll calculate, if I give you a drug and I say it's 5 mg per pound, you would do 5 times the weight in pounds, say it's 40, that'd be 200 milligrams. And then if I told you, you know, it's 100 milligrams per tablet, you would divide 200 by 100, and you get the 2. Now that was probably not the best example because that all worked out evenly. But what I'm saying is, if that wasn't a perfect number to draw up, you know, for the purpose of a math test, I would want you to put the number not rounded or not affected. Clinically, you would have a conversation with the doctor and decide, are you going to round up or you're going to round down? Because it's their ultimate decision. If it's a prescription to go home, if it's a sedative for anesthesia, if it's an anesthetic, it's their call as the doctor. So don't clear out the calculator till you get to the very end of your math. Let me stop here because and it's 1:18 and I want to get into this a little bit. Tomorrow I can show some more pictures and stuff. So let me stop here. Do you have any questions. Let me unmute everybody. Everybody's unmuted for a second.